Hey there, in previous lessons we went into in-depth detail about the where keyword and the and keyword. Those allowed for filtering the records returned by our query. In this lesson we're going to complete our understanding of how filtering works in SQL, and we'll get plenty of practice applying the or keyword with a combination of the and the where. So make sure you complete all of the puzzles I ask you to work on in this lesson. This is very crucial stuff. After practicing the puzzles in this section, you'll really gain the confidence in SQL and grow from there, because this is a real foundation builder for data analysis and SQL querying. All right. Now I'm going to repeat some key concepts in multiple different ways, so it might get annoying, but I'm going to keep repeating it. Certain things, I'm going to say it over and over again in multiple ways until you understand, right? I don't intend for you having to watch this lecture a bazillion times to understand what's going on. You should be able to just watch it in one go, and hopefully it should make sense. And then we'll get into some practice problems, and you'll be able to apply what you've learned and get practice. Now let's start. I'm going to sign in here into the apex.oracle.com website as we've been doing. Here are my credentials. I'm just going to sign in and go to SQL Workshop and SQL Commands. And this is the interface for typing in our SQL. So let's go over our first example. I'm just going to get a bare bones SQL query. Select star from employee. All right, so we're going to run this query and get all of the data in the employee table. And I'm going to increase the rows that are returned to 20 so that we get all of the records. Employee table contains 14 records, so I just want to see all of them. Let's hit run and we get, well, I think I have to highlight the whole thing. I can't just click on a particular word and run. So I highlighted the whole thing, I hit run, and we get all of the data in this table. Now let's say that we want to get all of the records, all of the employees that are clerks, for example. Right? And I could see that we have a couple of clerks in this table. So what I could do is I could do where job, right, where the job column contains the data clerk, like that. Okay. So again, these filter conditions, this where and so on, these are applied at every single record, and the records that match this condition are the only ones that are returned in this output, right? That's just how SQL querying works. So to see data, right? When I run this, I only want to see the data where the job contains the word clerk, and those are the only records that are going to show up. So let's hit the run button and notice that we get all of the clerks to show up. All right. Now let's say that the requirement comes up to return not only clerks, but also salesmen in the company. So now I want to see both clerks as well as salesmen. So what would you do in that case? Newcomers to this language, to SQL, often think that they can do and do job is equal to salesman, okay? Like that. And think that both the clerks records as well as the salesman records are going to show up. But this is not accurate, okay? And I'll explain to you the reason. So for example, this condition is being applied at every single level. That's why these records are being returned. Smith, the record containing the data Smith in the ename column contains clerk in the job field. Adams contains the word clerk in the job field. James contains the word clerk in the job field. Miller contains the word clerk in the job field as well. Now, when we add this extra condition and say, and job is equal to salesman, including this and, I'm making it compulsory. I'm making it a must for the job column to also contain salesman. And this is logically inaccurate, okay? You can't say that the job column must be equal to clerk and the job column must be equal to salesman for every record, right? It's either or. So logically, it's not correct. Having an and there makes it compulsory for the second condition to also be true for every single record, and that's not possible. It's sort of like me saying, my birthday is January 1st, and my birthday is June 12th. It's either or. It can't be both, right? So if my information was here and my name was in this table, I would have a particular record. And let's say there was a column for my birthday. That column would only contain one data, right? It would have either January 1st or March, or June, whatever the date is. It would be a single date, and it would be completely incorrect for me to say where birthday is equal to January 1st and birthday is equal to June 12th. That is completely inaccurate. It's not logical to hold every single record accountable for this criteria. It doesn't make sense. I was either born on January 1st or I was born on June 12th. So if I highlight this and hit run, no data, right? No data found. So to fix this, let's see all of the data again in the employee table. I'm just going to highlight this first line there, hit run, and this is going to give me all of the data in the employee table. Now, when I run it with this statement right here, this is going to filter out only the clerks. And then when I add this and job is equal to salesman, this is going to try and make sure that this job column must have the data salesman in there, and it does not. So this is completely not going to work. Every single one of these filter conditions, whether it's an equals or less than or greater than, as you'll see soon, is being applied for the particular column for that record, right? The job column must contain clerk and job column must contain salesman. This is not going to work. So we need the or clause. This is where we can use or, right? And now when I run this, select the whole thing and hit run, or you don't even have to select it. Since this is the only statement in the editor, just hit run. And notice we get all the clerks as well as salesmen in our company. Okay? So what happened here? Well, it was doing the same filter condition here where it was checking for job is equal to clerk. It returned that record. Or job is equal to salesman. So it was basically applying both of these conditions, this filtering criteria on every single record, right? And that's like, you can just look through the data yourself and ask yourself the sentence. Does Smith contain the value clerk or salesman in the job column? Yes, it does. Does Alan contain the word clerk or salesman in the job column? Yes, it does. Does Ward contain the data clerk or salesman in the job column? Yes, he does, and so on, right? That's in English, that's exactly how you want to look at it, okay? So this is why we're able to get all of the clerks as well as salesmen in our company. We can't use and, right? Because if there was and here, then I would have to read it as, does this first record contain the word clerk in the job column? Yes, it does. And does this first record contain the word salesman in the job column? No, it does not, right? Notice that I'm checking for that same exact column based on two different conditions, right? Those two conditions need to be correct for that record to return, and that will never be the case, right? Let's do another example. Remember, these filter conditions, where and so on, are applied at every single record, right? Every single record is being checked for these conditions. And for those records that hold true for both of these conditions, those are the only ones that should be returned, right? So let's take another example. Let's take the example of, say, the record with Ward as the employee, the third record. So when the SQL interpreter is executing our query and checking each one of these records, when it gets to this record, it's going to check, does this record contain the word clerk for the job column? No, it does not. And does this record contain the word salesman for the job column? Yes, it does, but it doesn't matter because both of those conditions need to be true because we would be using an and that's not going to work. So with the and clause here, none of these records will be returned. Now, if we change this query to use the or clause where job is equal to clerk or job is equal to salesman, all of these records will be returned. They all qualify. because it's either or, either a clerk or a salesman. If either one of those conditions is true, the record is returned. All right, here we are back in the editor. Now I've spent plenty of time drilling into you the point that these where and conditions, these filter criteria, is checked on every single record, all right, of the particular table. And those records that match these conditions are the only ones that are returned. Now it's time to put this knowledge to work. It's time for you to complete a problem, and make sure you really take the time to work on this on your own before moving on to my solution. SQL or any other programming discipline is all about practice, practice, practice. Now, if this puzzle is challenging for you, great. That means you're going to learn something, okay? You have all of the knowledge in the previous lessons that I've been going over for you to be able to complete this problem, okay? You have the prerequisite knowledge. Now it's just about the struggle and trying to work this problem out. So here it goes. Write me a query that returns the name of those employees that are not managers nor salesmen and have a salary greater than or equal to 2,000. So I'm going to pause the video here, and you can work on this and then resume to watch my solution. All right, welcome back. Hopefully you took time to work on this on your own. Now let's start with first analyzing the table. All right, I'm going to write the bare bones select statement against the employee table. So we get all of the records, and I'm selecting 20 records, so I see everything, all of the data. And remember, before, like I said before, you want to identify those records that you expect to be returned. All right. So I don't want to see any managers, nor do I want to see any salesmen, according to the requirement. And I want to see those employees out of that subset that have a salary greater than or equal to 2,000. So all of these salesmen are not supposed to show up in my query, as well as these managers. They're not supposed to show up either. So I'm only concerned with the presidents, the analysts, and the clerks. And let's see which one of these have salaries greater than or equal to 2,000. And it looks like this analyst here, he's making 3,000. And this analyst right here, he's also making 3,000. And this president is making 5,000. This manager, he makes 2,850. But remember, the requirement is I don't want to see managers nor salesmen. So I have an idea as to what I expect to be returned when I write the correct query. So now let's start working on filling the requirement. So I need a where clause, and then I want to filter for where job is not equal to manager. So now if I run this, it's going to show me all of those employees that are not managers, okay? Now I also need to filter out the salesman. I don't want the salesman either, right? So for that, now you have to make the critical decision of whether to use the or clause or the and clause. And newcomers to SQL often get this mixed up. And let's try the or clause first, and I'll show you exactly what happens when I do this. And I don't want to see salesman either, right? So now we have where job is not equal to manager or job is not equal to salesman. And newcomers often get this wrong. So if I run this, watch what happens. Whoa, I'm getting the managers and the salesman. As a matter of fact, I'm getting all of the rows in the table. So what happened here? Well, remember, both of these conditions, all of the filter criteria is applied at every single record, and the records that match that criteria are the ones that are returned. So let's ask ourselves a question. Let's look at the first record and ask, is the job not equal to manager or job not equal to salesman? Yes. So this is supposed to return. So far, so good. This one I did not expect to return. Why is it showing up here? Well, let's read our conditions and see if it makes sense. Where job is not equal to manager, well, this is definitely not supposed to show up. But then over here I'm saying or job is not equal to salesman. Okay, so either one of these conditions should be true. And lo and behold, this condition, job not equal to salesman, is true for this record, right? Either one of these conditions should be true with an or. That is why this manager is showing up, okay? That's why all of these managers are showing up. Now let's head over to the salesman, and we apply this condition where job is not equal to manager. That's true. It's not equal to manager, or job is not equal to salesman. Well, this is definitely not supposed to be returned according to this job not equal to salesman part. But guess what? I'm making that optional because I'm saying where job is not equal to manager or job is not equal to salesman. So that's why these records are showing up. So nothing really is being filtered here because of this or clause. So let's make that an and. And now if I hit run, the managers nor the salesman are being returned. Okay, so now it's going to go through every single record and check for these both conditions. They both must be true. Job is not equal to manager and job is not equal to salesman. And that's why we only have these 7 records now. So this is the correct subset. We filtered to a certain point. Now we need another condition. And Sal is greater than or equal to 2000. Okay? And hit the run button and notice that we get the records that we thought we should get, right? These are the analysts and they make 3,000, and then the president, he makes 5,000. Now we're not completely through with this problem. Remember, the requirement was for you to return the name of those employees that are not managers and that meet this criteria and so on. The names of those employees. So which column here contains the names? It's the e-name column. So instead of this asterisk, we can specify the exact column that we want to be returned, all right? And select the whole thing, hit run, and we only see these names, King, Scott, and Ford, okay? Now, using the asterisk is very handy to analyze the data, and when we are ready to fulfill the requirement, when we're getting closer to the actual requirement where we just want to see the names, then you can just replace that asterisk with the specific column that we want, because we know based on all of this criteria, the data that we get back, these names, these employees, all fall within this criteria. Now we're not through yet. I have one more puzzle for you to work on before this lesson ends. And that is for you to write me a query that returns the names and hiring dates of those employees that work in Dallas or Chicago. Okay? And this is a tricky one because it requires a little bit of data analysis. Let's select star from emp to see the entire, all of the records in the employee table. And notice that we have these department numbers, okay? And these numbers are actually repeated in another table. Select star from DEPT. Remember this table we went over a little while ago? This is another table that we'll be working with. So select that and notice that we get the department table here. And I only want to see those employees that work in Dallas and Chicago. There are only 2 columns that I'm interested in. The names as well as the hiring dates. That's it. The e-name and the hire date. And both of those attributes are in the employee table. So let's take a quick look at employee again. And these are the columns, the hire date and the e-name. These are the only 2 columns that I want to see for those employees that work in Dallas and Chicago. And you can look that information up in the department table. Because remember, the department table also has the department number, and this is a commonality between both of these tables. If I run the department table query here, notice that the department number is repeated here, and based on the Dallas and Chicago, you can filter for that in the employee table and get the information that I'm looking for. Now we're heading into the area of relating both of these tables together, and they are in fact related by this department number column. Both of these tables contain the department number column, and we're soon going to be talking about joins. So I want you to start thinking in that direction. You don't need to know joins to solve this particular problem, but we're going to pretty soon get into how joins work, and hopefully this will be a segue into that topic. So give this puzzle a try, and in the next lesson we'll go over the solution as well as build up on the syntax that we've learned about, and we're going to talk about the in clause and some other cool stuff. So stay tuned.